Greetings and a very warm welcome to today's learning session. I am Dr. Neelima Budhani, Assistant Professor from School of Computer Science and IT at Uttarakhand Open University, Haldwani. Today, we will explore the topic of cryptocurrency and blockchain security. Let's begin by going over the main learning objectives for today's session. First one is understand the basic concept of cryptocurrency and blockchain technology. Second is explore the role of blockchain in enhancing financial inclusion. Third, explain the working process and decentralization nature of blockchain system. Fourth, identify security feature and common threat in cryptocurrency networks. In the last lecture, we discussed about advanced cybersecurity practices. Let's start with introduction to cryptocurrency and blockchain, in which first of all we will define cryptocurrency. Cryptocurrency is a form of digital money. You cannot touch or see it like coin or notes, but you can use it online. It uses cryptography, which means special codes to keep transactions safe and private. Unlike regular money controlled by bank or government, cryptocurrency is decentralized. This means no single person or group controls it. Instead, it runs on a system called a blockchain, which is like a public digital ledger that records all transactions. Example like Bitcoins and Ethereum. Let people send and receive money online quickly, securely and directly without needing a bank in the middle. Bitcoin and Ethereum provides a way to exchange value online in a way that's more like sending an email than making a traditional bank transfer. Next is, what is blockchain? Blockchain is a type of digital ledger or record keeping system that stores information in a secure, transparent and decentralized way. Instead of being stored in one central place, the data is spread across a network of computers called nodes. Each piece of information is stored in a block, and these blocks are linked together in a chain. Hence, the name blockchain. Once data is added to a block, it cannot be changed or deleted, making the system secure and tamper-proof. Blockchain is the technology behind cryptocurrencies like Bitcoin and Ethereum. But it also has many other uses such as banking, supply chains, healthcare and voting system. Blockchain is decentralized, meaning it is not controlled by any single authority but instead operate across a distributed network of computers. This eliminates the need for central intermediary and increase trust among participants. Blockchain is also immutable. Once data is recorded, it cannot be altered or deleted, ensuring the integrity of the information. Additionally, it is highly secure. Each block in the chain contains three key elements: data, a timestamp, and a cryptographic hash of previous block. This hash links the blocks together in a secure manner, making the entire chain tamper-proof and reliable. In easy words, a blockchain is a shared digital notebook that everyone in a network has a copy of. When something new happens, like sending cryptocurrency, it gets written down as a block, and everyone's notebook gets updated with that block. This new block is then linked to the previous block in the notebook. using a specific special cryptographic code. Next is financial inclusion and crypto. Here we will talk about how cryptocurrency promotes financial inclusion. It points out that crypto offers decentralized financial services operate without a central authority, enabling peer-to-peer transaction and financial management through blockchain technology. Borderless and decentralized financial service empowered banked and underserved population by enabling them to access, store and transfer funds across geographical boundaries without relying on traditional banks or intermediaries. Case studies like Bitcoin is increasingly used in remittances, allowing people to send money across borders with lower fee and fast transaction time. This enhances financial inclusion by providing a more accessible and cost-effective alternative to traditional remittance services. Now, move towards how blockchain works. First of all, we will understand blockchain structure. The key element of blockchain technologies are blocks. Blocks are digital containers that hold batches of valid transaction. Each block includes transaction data, a timestamp, and a references to the previous block, forming a continuous chain. Second is hashes. Hashes are unique digital fingerprints generated from the block's data. Any change in the block's content alter is hash, making tampering easily detectable. Third one is chains. Chains links blocks together using their hashes. Each block refers to the hash of previous ones, creating a secure chronological chain of transaction that is resistant to tampering. Together, blocks, hashes, and chains create a secure decentralized structure that ensure data integrity, transparency, and trust in blockchain system. Decentralization explains a core principle of blockchain technology. No central authority, instead of being controlled by a single institutions such as a bank or government, the system is decentralized with authority shares among the users. Peer-to-peer network, participants or nodes communicate and transact directly with each other without intermediaries. Each node independently verifies and approves transaction, maintaining trust and accuracy throughout the network. Enhanced security and transparency. Since data is distributed and verified by many participants, the system becomes more secure, harder to tamper with, and more transparent to all users. Now, the process of blockchain outlines the step-by-step flow of how a blockchain transaction works. Number 1, a user initiates the process by submitting a transaction request. Second, the transaction is then grouped with other to form a new block. Third, nodes on the network validate the block to ensure its accuracy and legitimacy. Fourth, after verification, the block is added to the existing blockchain in a secure and chronological order. Number 5, the transaction is finalized, permanent and visible to all participants on the network. This process ensures transparency, security and immutability of transaction on the blockchain. Next, why blockchain matters. Highlights the key advantages and benefits of blockchain technology. First one is security. Cryptographic hashing protects data, making it highly resistant to tampering. Second is transparency. All participants in the network can access the shared ledger, promoting openness. Third is efficiency. By removing intermediaries, blockchain streamlines processes and reduces delays. Fourth is trustless system. Users don't need to rely on or trust a central authority as the system itself ensures integrity. Now, let's explore the security feature of the blockchain. Key security features outlines the core security elements of blockchain technology like cryptography hashing. Convert data into a unique fixed size hash value as secure hash algorithm 256-bit, where even the tiniest change in the data result in a completely different hash, ensuring data integrity. Immutability. Once a block is added to the blockchain, it cannot be changed without altering all following blocks, making tampering practically impossible. Next, decentralization. Data is distributed across many nodes, so there is no single points of failure or control, enhancing security and resilience. More security enhancements. Details further security feature of blockchain technology. Consensus mechanism. Methods like proof of work and proof of stake ensures that all participants agree on a validity of transaction before adding blocks. Smart contract controls. These are automated contracts that execute themselves when predefined conditions are met, reducing the need for intermediaries. Next, private or public key cryptography. This system guarantees that only authorized user can access the blockchain or initiate transactions, enhancing security and control. Now, we will discuss common cryptocurrency threats. First is key threats in cryptocurrency ecosystem, focusing on major attack vectors. Number one is phishing attack. These involves fake wallets, exchanges or email that deceive user into revealing sensitive information such as private keys. Once attackers get this data, they can access and drain user crypto wallets. Second, malware and key loggers. These are malicious programs that infect devices to steal wallet credentials or intercept transaction. Keyloggers, for instance, secretly record everything typed on a keyboard, including password and private keys. Rug pulls and scams. In this type of fraud, developers launch fake crypto projects, attract investment funds, and then suddenly disappear with the money, leaving investor with worthless tokens. Impersonation and social engineering. Attackers pretend to be trusted figure or organizations like support staff or influencers to trick users into revealing sensitive information or sending payments. Second type of threat is technical attacks on blockchain network. 51% attack occurs when a single group or entity gains control over 50% of blockchain networks, mining or hash power. This allows them to manipulate transactions such as double spending coins or blocking new transactions. Next, Sybil attack. In this attack, a malicious actor creates a large number of fake identities to flood the network and disrupt consensus, potentially gaining disproportionate influence over decision or operations. Next, smart contract exploits. Vulnerabilities or bugs in smart contract code can be exploited by attackers to steal funds or manipulate behavior. A famous example is the DAO hack, where flaws in the contract allowed hackers to drain millions in cryptocurrency. Double spending. This occurs when same cryptocurrency is used in multiple transactions, effectively spending it more than once. It typically happens due to timing issue or verification delay in the network, compromising trust in the system. Now we will discuss real world example of Bitcoin hacks. First is Mt. Gox. Once the biggest Bitcoin exchange lost 850,000 Bitcoin due to a long unnoticed hack. Lesson is poor wallet security and lack of regular audits can cause huge losses. Secure cold storage and audits are vital. Second is Bitfinex hack in Bitfinex hack 2016. Bitfinex lost about 120,000 Bitcoin after hackers exploited weakness in their multi-signature wallet system. Lesson is even advanced security method like multi-signature wallet must be properly implemented to avoid vulnerabilities. Next is Ronin network hack in 2022. Hackers stole over $600 million by attacking the weak link between Ronin sidechain and Ethereum. Lesson is cross-chain bridges are vulnerable and need strong access control and frequent security testing. Fourth is NICE has hack in 2017. $64 million worth of bitcoins was stolen after an attacker hacked an employee's computer. Lesson is insider threats and endpoint security are critical. Employee devices must be well protected. These examples show how the importance of strong security practices, including proper wallet management, secure system design, regular audits, and employee device protection in the crypto world. Now, learning outcomes. After completion of this lecture, the learner will be able to first define cryptocurrency and blockchain with real world example. Second, describe how blockchain support transparent and secure transaction. Third, explain the step-by-step process of how blockchain operates in decentralized system. Fourth, list major security features of blockchain and common cyber threats in cryptocurrency. In the next lecture, we will discuss about cryptocurrency and blockchain security part 2. Thank you, learners.